Hi everyone. Today we'll be going over an example for designing a wood column in ClearCalcs. So let's head over to the wood column generic concentrically loaded column template and pop that open. So the column we're designing today is a corner column, an exterior corner column that'll take both lateral loads as well as gravity loads. It's a 10-foot tall column and not braced in any direction. So let's put the geometry in. It's being loaded from the roof load with uh, 40 PSF um, of dead load by 100 square foot, and then actually it's only being loaded by 60 PSF of snow load by 100 square foot. So let's change that to snow. We can also put in the live load. So the live load, because it's a roof, is only 2,000 pounds. Um, and our load combinations will take everything into consideration. And because we know that the load is being transferred in from a beam that's connected in, the load is not concentric and is actually being applied uh, from the beam to the column. So it's being applied actually at an eccentricity of, we usually consider the depth of the column over 6 as, as the eccentricity. So now we've applied our actual load as well as an eccentricity on it. There's 15 PSF of wind load. So let's add that in from the column, and this column is taking about 10 foot of tributary width. And the same thing what happens in the y-axis. So it's also there's also eccentricity coming in from the beam connecting on the weak axis of this beam. So here we can also use d over 6, and then we can apply our weak axis wind load. So here is also 15 PSF from 0 to the length of the column, and it's with a tributary width of 10 feet. So once we put all that information in, we can go over the rest of the parameters. It's not repeating because it's a corner column. It's in dry service condition, and we expect the temperature range to be within 100 degrees Fahrenheit. There's no notches and shear deflection is not of particular concern here. It's a standalone column, and so we're not going to check for bearing in this one. And then our load combinations will take things into consideration, whether live governs or snow governs, or a combination of the two. So once we've considered that, all the inputs are done, and we can go up and actually design our column. This column is this particular 6x8 Douglas fir is only at 63% utilization. So based on the type of column, the type of wood we want to use, we can use my dimensional lumber and say actually we want, keep scrolling, we can sort of try a something with a high utilization like a 2x12 or a 2x14. And what we can do is use multiple plies. So because we do know that this is a corner column, we can use three plies and see that this passes. Maybe our wall doesn't have like the width for 14 inch deep ply of wood. Now that we've put in 3 plies, we can check the size and grade again. And all of these numbers that are being shown here are for 3 plies of this type of wood. So now we can try maybe a 2x8. Would any of the 2x8s work? It doesn't seem so. And then we can up that to 2x10 in dimensional lumber. So it seems this 2x10 just passes. And of course, these the wood you would pick you would likely actually filter by species or grade based on what's available to you But for this purposes, we can use 3 plies of 2 by 10 here, and we can see that that this column has been just designed for actual combined with x-axis and y-axis bending, as well as any eccentricities from the connections coming in. And yeah, that's all for this example.